Let's see how to find the derivative of an integral. So that can be found using the fundamental theorem of calculus. So what is this fundamental theorem of calculus? If you have a function that is continuous on the closed interval ab, then the integral can be found out as integral a to x f of t dt if it is continuous on the closed interval ab, and if it is differentiable on the open interval ab, then its derivative, the derivative of the integral, can be found out using f dash of x is equal to d by dx of integral a to x f of t dt, and the value of this derivative of the integral will be equal to f of x. Means whatever f of t you have will be replaced by x, and that will be giving you the solution. Suppose you have the derivative of integral in this form. So we have d by dx integral a to x, where a is a constant. Constant can be any numbers from a to a variable x, f of t dt, which is equaling f of x. So let's see a problem on this. So how to solve a problem using the fundamental theorem. So you are given with y is equal to integral a to x t cube plus 1 dt, and we are asked to find out dy by dx, that is the derivative of given function. So how do you solve this? So we know that y is equal to integral a to x t cube plus 1 dt, and if you look into the theorem, it says d by dx of the integral, and we want here dy by dx. So we are going to differentiate. Differentiating, we get dy by dx equals d by dx of integral a to x t cube plus 1 dt. So see, you are going to compare the given formula with the problem we have now. D by dx and d by dx, integral a to x, same integral a to x. In place of f of t, we have t cube plus 1 and dt. So we can say here f of t is equal to t cube plus 1. So what do we have the solution? If you have the given integral derivative of an integral in this form, then the answer will be equal to f of x. So what will be f of x here? So f of x will be equal to x cube plus of 1. So the solution for this derivative of an integral is x cube plus 1. So another thing to be noted is the integral should be from a to x, a constant to a variable x. Let's see another problem. Example 2. If y is equal to integral x to 5 3t sin t dt. So we are asked to find dy by dx. So we have y is equal to integral x to 5 3t sin t dt. So if you want to find out dy by dx, we need to differentiate. So differentiating, we get dy by dx, that equals d by dx of integral x to 5 3t sin t dt. So before we apply the formula, we need to check whether whatever we have here is in the required form. So this is the formula here. D by dx we have integral a to x, but here you can see x is here and we have 5 here, so that should be reversed. So we can reverse that by multiplying by minus sign. So d by dx remains as it is. Integral can be changed by reversing the bonds, that is 5 to x 3t sine t dt. So now it's in the required form a constant, that is a equal to 5 to x f of t dt. So take out the minus sign. So we have minus of d by dx integral 5 to x 3t sine t dt. So now we can say here f of t is equal to, on comparing, 3t sine t. So we know that if you have the integral in this form, then the answer will be f of x. So therefore, what will be the value of f of x? F of x will be equal to 3x sine x. So the solution here, since we have a minus sign, keep the minus sign, 3x sine x. This will be your required answer. We'll see another problem. Example 3. The given question, y equals integral 1 to x square cos t dt. So if we compare, we can see that the value of y is from 1 to x square, but here it is from a to x. Constant is okay, but in place of x we have x square. So whenever you have a variable other than x square, like x cube, x square, or whatever other than x, then that should be taken as u. So we can say let y is equal to integral 1 to u cos t dt and u is equal to x square. We are doing this because the variable is not x and we have something other than x. So that should be taken as a variable u. So now we are supposed to find out dy by dx. So as we know the chain rule of differentiation, so applying chain rule to find dy by dx. Dy by dx will be equal to dy by du times du by dx. Since y is in terms of u, I have differentiated y with respect to u, and u is in terms of x square, we are differentiating u with respect to x. Now we just substitute the values here. D by dx remains same. Y value we know from the question, it is integral 1 to x square cos t dt. So that equals d by du of, so whatever y we have taken in terms of u will be replacing here. It is 1 to u cos t dt multiplied by d by dx of x square. So we proceed. So you can see it is in the required form, d by dx integral 1 to u f of t dt, whose value will be f of x. See, if you have here x, you will be having the answer as f of x. So since I have here u, cos t will be written as cos of u times d by dx of x square, or else it can be written as u, that was x square. Now we replace. What is the value of u here? U we have considered as x square. So in place of u, we are going to write x square, and d by dx of x square is 2x. So therefore our answer comes as 2x cos of x square. Okay, this is how you're going to solve when you have any variable other than x. Look into the another problem. Question 4. So here you have y equals integral 1 plus 3x square to 4, 1 over 2 plus e power t dt. So if you observe the integral, you should have the constant at the bottom and the variable at the top. So we'll rewrite this. So y will be equaling minus, since you're going to change the places here, so it goes as 4 1 plus 3x square 1 over 2 plus of e power t dt. Okay, so now since we are going to find out the derivative, we are going to differentiate this. Again, since we have here some other value instead of x, this is supposed to be taken as u. So we'll be applying chain rule. Y will be replaced as dy by dx, that equals dy by du times du by dx. Now since you know the value of y from the equation that is given is d by dx of integral substituting the value of y from the given equation, that is 1 plus 3x square to 4 d by dx integral 1 plus 3x square to 4 1 divided by 2 plus e power t dt, that equals d by du of y. Since you want y in terms of u, so we can replace, therefore y will be equal to minus integral 4 to, consider the value of x as u, 1 over 2 plus e power t dt, and u equals 1 plus 3x square. Now we substitute value of y, which is equal to minus of integral 4 to u 1 over 2 plus e power t dt multiplied by du by dx, or you can put the value of u. So now we are going to simplify this. Take this minus sign out of the integral. So it is minus of d by du integral 4 to u 1 over 2 plus e power t dt, here du by dx. Now since you can compare d by dx with d by du, integral a to x as 4 to u 1 over 2 plus e power t as f of t, which will give you the value of f of x. If you have d by dx, answer will be f of x. If you have d by du, you'll be getting the answer as, keeping this minus sign, 1 over 2 plus e power u multiplied d by dx of u. So what is d by dx of u? What's the value of u? We have the value of u as 1 plus 3x square. So now substituting the value of u, 2 plus e power u. We have considered u as 1 plus 3x square. 1 plus 3x square times differentiation of 1 plus 3x square. Differentiation of 1 will be 0. Since 3 is a constant, keep it as it is. X square differentiation will be 2x. So we simplify this and write the final answer. Since I have a minus sign, minus times 3 times 2x will be minus of 6x whole divided by 2 plus e power 1 plus 3x square. And this is the required final answer. Let's consider another example. Example 5. Find d by dx of integral 0 to x square root of 1 plus t cube dt. So again we can see that it is a derivative of an integral. So we'll start considering the value of y. So let y is equal to integral 0 to x square root of 1 plus t cube dt. So we know that this is not in the required form, that is it's a to x, constant is 0, but in place of x we have x square. So this x square have to be replaced by u. So y is equal to integral 0 to u, and u is equal to x square. Now simplifying this equation, applying chain rule, dy by dx will be equal to dy by du multiplied by du by dx. D by dx as it is, putting the value of y, that is integral 0 to x square root of 1 plus t cube dt, that equals d by du of, considering the value of y where we substituted u as x square, that is integral 0 to u square root of 1 plus t cube dt multiplied by d by dx of u, that is equal to x square. So you can compare this with the integral formula d by dx, integral a to x f of t dt, which can be replaced by f of x. So here f of x value is square root of 1 plus t has to be replaced by u. So it is u cube, and d by dx of x square as it is. Now, what is the value of u? The value of u is 1 plus u is x square. So it is x square whole cubed, and derivative of x square will be 2x. So simplifying this, 2x, we'll write it in the big front, square root of 1 plus x square whole cube. 2 multiplied by 3 gives us 6. So the final answer will be 2x square root of 1 plus x power 6. Going to the next example, example 6. So again you can see here it is the derivative of integral sin x to cos x 1 minus t square whole square dt. Now here we can see y is equal to integral sin x cos x 1 minus of t square whole square dt. So since you want from a constant to a variable and both of these are variable, we can split this as integral sin x to 0 1 minus t square whole square dt plus integral 0 to cos x 1 minus of t square whole square dt. So you are using here integral a to b f of x dx can be written as integral a to c f of x dx plus integral c to b f of x dx. This equals, since we have two integrals, again checking if it is from constant to a variable. So this is a constant and this is a variable. So we are going to change the bonds here. So it is minus of integral 0 to sin x 1 minus of t square whole square dt plus of integral 0 to cos x 1 minus of t square whole square dt. Now if we differentiate, that is dy by dx will be equal to minus of d by dx of integral 0 to sin x 1 minus of t square whole square dt plus d by dx of integral 0 to cos x 1 minus of t square whole square dt. So we can apply the rule here directly. Since we have minus of integral d by dx of integral 0 to sin x 1 minus of t square whole square dt, you know that this should be x, then f of t can be written as f of x. So here f of x value will be 1 minus of t square whole square. Since you have your sin x, in place of t we will be putting it as 1 minus of sine square x whole square. So this will be 1 minus of sine square x whole square, and then the derivative of d by dx of sin x, plus, again this is in the form of d by dx, integral 0 to x 1 minus of t square whole square. This will become f of x. So where f of t is this, f of x will be 1 minus of cos square x whole square. I'm going to substitute in place of t cos x because we are finding the value of f of x, and then the derivative of the x, that is cos x. So now simplify, 1 minus of sine square x whole square. We had a minus sign here, so I'm putting the minus sign. D by dx of sin x is, derivative of sin x is cos x, plus 1 minus of cos square x whole square, and the derivative of cos x is minus of sin x. So the final value, that is dx of y, that is derivative of sin x to cos x 1 minus of t square whole square dt equals minus of 1 minus of sin square x whole square times cos x. Since you have a minus here, plus times plus into minus will be minus. So it is minus of 1 minus of cos square x whole square into sin x. This will be your final answer. Looking back into the previous problem, here instead of doing this chain rule, you can also do the problem directly. That is, you can see here that d by du integral 0 to u f of t dt can be written as f of u. That is, we write the f of t value and replace t by u, and we find the derivative of u, that was our x square. So in place of u we put the value of x, that is x square whole cube, and we find the derivative 2x. So the answer will be 2x square root of 1 plus of x power 6. So this method can be done directly, that is f of t will be written as f of x, and then we find the derivative of the value of x, whatever is the value of x, that will be differentiated, and that will be your final answer.